Hempcrete essentially, hemp hurd, which is the inner woody core of the hemp stalk, with the lime-based binder and water. Thousands of years old, and what it makes is a mold-resistant, pest-resistant, rot-resistant, and fire-resistant, ultimate in indoor air quality, carbon sequestering construction infill that self-regulates vapor permeability and self-regulates humidity, self-regulates thermal performance. In Hempcrete, obviously, it's an infill. If we could go back and rename Hempcrete, we would. We'd call it Hempfill, because it gives people the misimpression that Hempcrete is a substitute for concrete. And actually, it's not. It has to be above ground, daylight. It's a living, breathable wall system that cannot touch the earth. I think what the most interesting thing about Hempcrete is that when we're talking about a climate such as we're here in Portland, we don't actually need to include a heating or a cooling system. Ultimately, we could save the money in not installing those systems, but if we did, they could be less strong systems, particularly when we get into HVAC and larger builds. And then, of course, we save the money and the energy from not having to use those systems. So we're talking about a smart income home as well. Of course, when we talk about modern day construction, we're talking about buildings that last maybe 50, if you're lucky, 80 years. More than 50% of our landfills are actually filled with construction waste from these basically temporary homes. A 40-year home is a temporary home. When we talk about Hempcrete, we're saying these homes will last 300 to 500 years, perhaps even longer. And that's not a guess, that's not an estimate, because Hempcrete is new. Again, this is thousands of years old. We have existing Hempcrete structures in Japan, in India. So ultimately what we're talking about is a home that is durable and frankly reusable and recyclable. It's truly the ultimate building material. There's nothing better than Hempcrete.
All right. Good morning. Coming at you from southern Colorado. Trying to describe some exploitability about hemp fiber and its bindings with like a lime or a Portland type binding. Here's the Puritan lime is what I would call this one. It's I'm sorry if you can only see the little pointer, but I'm going to use stainless steel for the picking action. Lime does a good job by calcifying the material. It'll hold together fine inside a wall. It's R75 at about 1 foot thick. I believe the K rating is like 50. It's insane. The properties of hemp, just the natural properties, mold resistant, hypoallergenic, it's everything a house should be built out of. Now you can step up the binding process with mixed design to a Portland. It needs to be stickier to hold to an organic material, and that's what the whole video is about. Portland in lime, no matter how you do it, it's not going to stick to an organic material. That's its failing point. You can modify that with different. I'm trying to get. Oh, the sun's already dropped. I was fighting the sun because you couldn't see, but now it's dropped so much you can't. It used to sparkle, is what it was on some of these test samples. Even modified where it's stickier, it's still compressively strong for its width, its mass. It would hold up its own type roof, not a heavy, whatever you want to call it, cheaper to manufacture and install roof. I can't call it modern because that's a laughing thing. Our roof system is why our roof and walls and the way that we seal up our house is why we stay sick. That's what I'm trying to get at. If you can see this one, this is what you can get, and this is stainless steel. And okay, maybe you can, yeah, there you go. You can scratch the surface, but you can no longer exploit the organic from its binder. There you go. That's a good one right there. There's this one, and then you can take, and that's a good shot on. exactly how much hemp can be put into the material. And it works just like aggregate, you know, the small and the fine aggregate, basically the same principle. It fills the gap. Now that looked like it did a lot of damage, but literally it didn't. Literally it didn't. Is what I'm trying to get at. Is this side was it's the smoothest side, and the other side I had to use a belt sander. I can't scratch this side at all. That's why I chose this side over here. But the blade that I was using broke, and it took out a chunk, and it made a section of this. But the only reason it got dusty like that is because the blade broke. I'll show you a different spot. There's an example. And anywhere where it's solid, you can't even make it scratch. But just an example of what you can do with hemp. Like a tunneling system. Hemp, I believe, would be the perfect tunneling system. The same fabric that these ingots are cast with could be woven behind the machine, fed through the machine in a woven tube. How to say that? When it's woven, it could be, you know, compressed, fed through the machine, and on the other side reversed, and as the machine fills it out, it becomes stronger. As a tube is stretched, a woven tube, as it's stretched, it gains strength, and it shrinks in size. It shrinks in overall length. So the tubing could be fed through the machine in bunch, you know, I mean, in long, you know, like a spaghetti, like a worm, bunched up. And then as the machine needs it, because they don't move very fast, ask Elon Musk. I think he said Gary the snail was beating his machine. It's kind of ironically funny. But a tubing could be wove extremely fast. An MGO composite, a true MGO, even this can cure in 4 hours, and this is not a true MGO. But a true MGO, I think, can cure in 1 to 4. It's even less. 80,000 PSI. It would make tunneling systems extremely safe, only because the once it's stretched, now it's the compressive tunnel. It could be re-drilled, and then the slurry pump behind it, like you would do for like well drilling and all that, to re-solidify the broken rock. You know, the even gravel. It could go through a gravel bed with no problem doing that. I've done some experiment. Some of these, I don't have one. I'm sorry, not handy at least. There was one of these where it was just dust, and I injected it and I pulled through to prove a point of concept. Worked just fine. Hemp fiber is a wonderful fiber to work with. It could be injected between the rocks to reinforce the concrete and everything else in the slurry. But, okay, enough of tunneling concepts, right? Kind of a topic. Another thing this thing could do is build a welcome center border wall. Instead of the Nazi dictator thing that they want to do, the steel wall, this could be hollow inside with airform. The airforms to cast entire building setups inside the wall. The wall could be 100 feet wide if you wanted it, 50 feet tall. It's, you know, insulated. You wouldn't have to heat it or cool it in that region. And but put Red Cross inside the wall. Put everybody inside the wall. You know, I mean, make the wall a warehouse. Make the wall, you know, everything you want it to do. You could build entire cities of this overnight. You can airform this. Pull the same fabric up over the top. Pin it, you know, you don't even have to like pin it to the airform. I mean, you pin it together, and then spray it with the MGO, and it'll calcify or turn to stone in, like I said, in about an hour. Then you can go back and shotcrete like this kind of a formula all over it, and this is much lighter, about half the weight of this, and it's probably twice the R value of this. The denser, that's the one thing that any of this is. The Puritan formula is the most R factor. It's the best. It has the very best R factor. Second, probably third, fourth, by far fifth. This is probably even third. I should say. I should have said third right here. It's the lightest and it's the densest. Let's see if you can see exactly how much wood. This is like the max amount of hemp that you can put in concrete and still get somewhere. And this is far stronger than reinforced fiber reinforced concrete. YouTube. Just doing an overview on some of these test tiles and ingots that I've made. This is the Puritan right here. This is lime. Well, it's not even the Puritan. I should say there'd probably one more back here. This is lime with bast and shiv deliberately crushed. This is the shiv only. This was purposely crushed, bass and shiv, purposely crushed bash and shiv. This is ground fiber, just, down to nothing near. This is ground down to nothing but put back together with adhesives. But we'll get to this in a minute. For the Puritan that likes if the tile, these are 9-inch tiles, if it was like 12 inches, it would be R75. Do the math for the rest of the, I'm not going to try to break it all down. And no, I don't give out recipes or you got to test. That's what this is. I'm just showing you what it's capable of. I'll tell you what I made it with. You do your own testing. I'm not going to be liable. Because you want to do it almost good enough. Okay. When I test this is not done almost good enough. I'm a researcher and it's repeatable. But enough on the disclaimer. This one, if it's hit, it's going to make a dust like that. If you can see this dust, but when it's sealed into a wall, it's no longer going to do that. And this was deliberately made with very little slurry or the lime, so you could actually see what was in the block is what it was for. This again is concrete done predominantly the same way. Excessive amounts of shiv. There's no bass in this one. It has a nice ring to it. I mean, this does too. These are all nice. This is what Hempcrete or hemp lime is. I mean, when people show you the houses, if it looks white, it's lime. If it looks gray, it's Portland. Then they can step it up from there, is what I'm trying to get at. It's been fortified, and fortified only means that it makes it sticky. I should say it's been stabilized to make it sticky. Fortification means it has like acrylic or latex, and acrylic is a monomer. It can grow roots into the medium, into organic medium, and that's why you'd use an acrylic. But some people can be allergic to it. But this one, it's been stabilized with caliche clay and a little bit of fine ground sand, just desert sand from southern Colorado. But does a real nice job. You can knock on this one. This is where it would start. These would be self-supporting if it had framework to hold up, the big mushroom top of a roof. The weight is about 250 pounds per square feet. But the walls are more than self-supporting. If you change that big mushroom top of a roof to hemp, it would be lighter, and then this could actually support the entire house. But from here on, this will actually support a conventional roof. This goes above and beyond 250 pounds per square inch, and that's not just static load. That's an aggressive testing. But concrete has a drawback, and I don't know if I can zoom in there. The Portland is not capable of binding to an organic material, and no sand and gravel is not organic; it's mineral. So you don't get for people that don't realize that. But an organic, Portland doesn't do well. Lime does not do well either. It probably doesn't even do as well as Portland. The Portland has clay in it, and that's what gives it a slight advantage over the lime. This is fortified. It has the bentonite, but it's lime. And now this actually holds to the fiber. The bentonite makes it sticky enough. Does it hold perfectly? No. It's not capable of that without fortification. And that's the next step, is adding an acrylic, a monomer, like an acrylic resin, into the Portland. You can get this. And it's Portland, but it's held perfectly. Won't zoom up. It's held perfectly to the fibers. This is still green, so I'm not going to hit on it. But it's not giving up anything on the fiber. It's not shrinking away. In bast, hemp, the shiv and the bast don't bring in moisture or won't take on moisture. You'll play hell even wetting it down to do it. In hot water works best. Just a hint, I'll save you a little bit of time on that. But is to get it to fortify with acrylic, to hold to the organic material. Now's when the crazier strength starts coming in, because bast is pardon me, hemp bast fiber is twice as strong as steel for its weight. The shiv is as strong as any hardwood. I would compare it to like aspen, non-grain orientated hardwood. But it's strong is what I'm trying to get at. This is purposely laid up. The layers, there's like 5 layers in that. I don't know if you can see them, but there's 5 layers. It was meant to be this way strong. In one of the videos down here, it's holding up a few hundred pounds this way and only holding it on the very edges. So it's extremely stronger than what it was designed to be. We got a winner there. This is the same composition, but solid, is the tube. And I made this column. It was a hollow column. And down here again, you're going to see this one pop up. And it's sporting a 5,500-pound truck. On its 3rd test, it fails. And what fails is the glue, the adhesive, pooled. It was a bad cast, and it didn't compact. And it pooled, and it froze at -7. So the fiber didn't fail. The adhesive failed. On its 3rd test, it was lifting up 5,500 pounds like a boss. This will do the same. It's just solid. But the fiber composition is the same. It's crushed material with a PLA adhesive. This steps up a different direction. This is nothing. This will be stronger even yet. This is purposely ground fine, but then using only nothing more than Elmer's glue. But this will actually be the next step up. Could it be made with other adhesives? Yeah, and it could even be stronger yet. But that's just where this is at. This is where it just gets wild. You couldn't hurt this with a sledgehammer. I try. I zoom up on it, like this to show you. I've done this one before. See that spot? You can't even make the hammer with the ball peen part dimple that spot. It won't. The fiber will not even dimple. So, good luck, Skippy, if you try to tear this up. I've tried 4 years. Not just that block, but everything else. The hemp is stronger than any organic fiber we have on this planet. Period. There's no way to say that. It's non-toxic like this. You can plant your plant right in the construction waste. It's fine, as long as you don't use a toxic binder. The material is safe for worms. You can use it for vermiculture, and the worm is. It's not like the skin on your armpits or your crotch. It's like the inside of your mouth. The worm is really super tender, and so there's nothing bad in hemp. Period. And it's good for the micro and macrobiology also. So that's just the way it is. I don't know how to say that. I can't say it any other way. And people that dog hemp because it's only insulation, they're talking about that one. They're not even talking about this one. And they're damn sure not talking about this fortified one or these other modified ones. They're only talking about these, and that's what they'll point and say, this is the only thing that we can do. Well, that's not true. Well, if that is, then you need to go back to school. Because there's all these others that you can do also, which is crazy in strength. This is 3/32. It's just all bass fiber. It was put together with the wrong epoxy. That was my bad. I should have read the can better. It can't be struck. The epoxy will fracture. The fiber won't, but the epoxy will. And to show you, I got a piece of it where it was only one fiber thick. Literally one fiber thick. And I had a guy up here, and that's this. It's a fiber thickness. If you can see that crack back there, and he was standing on it, punching on it and all that. And I am a martial artist of many years. And so I can hit something fairly faster. And I kept telling him, no, you have to hit it faster if you wish to do any damage. That's the only thing that can tear this up is speed. And so I punched it and I broke it, but not, it's just, it's like a car panel. It would be like, it's cool, but you can't tear that up. Here is the next. It stops here, and then I had 5 more, and I took them away because that's just a whole different thing. This is the first start of a geopolymer to use for stabilization and to fortify it. It does both, and it's using magnesium and aluminum and chloride, sodium chloride. But many ways to do this is what I'm trying to get at. You can use all magnesium oxide, magnesium chloride, and that makes that makes all that. But now this is crazy in strength. I don't know if I can do it. This is not even held on. It didn't, without vacuum, it's not going to pull through, on the cast. But here, okay. I did right there. Now that's hitting it like hard. Okay. This is green, or not really. It's not fully cured, but even now it cannot come loose of the organic. That's the key thing. And here on another side, there was a fiber that I did the same right here. I did the same thing with right there, trying to beat this little fiber loose. You can't even exploit one fiber of this. And now from this, and see it, and if the sun was right, you could actually see the crystals, the magnesium and aluminum, with any ide. It doesn't matter what chloride, what source of chloride you use. But any ide, it's gonna make crystals again, and but quite strong. This, wow. How to put that? These two are strong as non-reinforced concrete. They could hold up maybe 200 pounds per square inch, roughly. This gets to the modified ones. Gets to the. It surpasses that, is what I'm trying to get at. By the time you get to this, you're 10 times stronger than non-reinforced concrete. The very next step is a geopolymer. That makes it 50 times stronger. That's why I stopped, because it's lunar. You can't put these next 5 in the same bunch. You could build bridges and stuff in space from here. This is different, is what I'm trying to get at. It's hemp, but it's finally it's a chemical way to turn the hemp to stone, with MgO, with magnesium oxides, and with different. Well, I should just say oxides, and with chlorides, and modify it that way, and to make it bind to an organic, which concrete cannot. And this is still lime. It's still hydrated lime. The same properties. It has the clay, the bentonite in it. It has just been turned chemically to stone. And you can go farther. Like I said, the next 5 could build it could build a border wall. Several hundred feet, 30 feet to several hundred feet thick, 50 feet tall, internal buildings, R75 insulation, K50, hypoallergenic. The entire an entire quarantine area. You could make a border wall, instead of being an albatross and an eyesore, you could make it a welcome center to humanity. The things that we're doing down and around the world with our business model, I mean global business model, not just American, it's only going to make it worse. It's not going to make it any better. But here it is, folks. This is the building end of hemp. Let's get back and get off the philosophical crap. This is the building end of hemp. Beyond this, it just gets, this is spacey crap here. And the MGO stuff doesn't even need oxygen to cure, so it can really literally be used in space. Well, even here on out, it doesn't, these don't even need oxygen. This much, no. Let's do this right. Here. These don't need oxygen. Those do. These don't. The MGOs don't even, they need nothing. They bring all their stuff to the party. And, but here's strength, and I just wanted to show you, an overview of it all. And look at the other videos for the individual strength of all these different things. Like this poor thing this is a used block. It's a test tile. That's why it's got dust and dirty. It wouldn't do this normally. It would be more like this, a harder surface. It did 30 hours at over 600 degrees. And no house, nothing that we build with on Earth could do this. Even concrete fails that test. And some of them were well in excess. The stove, it was turning the plate red. Not the stovepipe. I mean the metal, the 1/4-inch metal plate. It was turning it red. So that can take a torch. From here, it can do some pretty impressive stuff. This is fireproof. Now, don't get me wrong. But to go through hemp, let me get on that too, is the fireproofness of hemp. To lance this, and that's the only way you're going to go through even regular hemp, would take liquid oxygen and a metal powder like aluminum. This would basically be the same. Aluminum powder and liquid oxygen would probably get you through all that, okay? It would start to fail about here. This is where it would start to fail. Aluminum powder and don't get me wrong, some of these you might even have to put in like iron oxide into the aluminum powder to make, to get the liquid oxygen to lance this. And when I say lance, I mean burn through it. It will not burn through. You could douse any of this with gasoline, any of this with diesel fuel, let the fuel completely burn out, and it would do less damage than that. By far less damage than this. That test was so extreme, it was just crazy. But from here on, even that, you're not going to lance this. Not without definitely changing the metal composition of the lancing material. Liquid oxygen, yes, probably even helium. From here on out, definitely the next step, it would take 5,500 degrees to even, well, it won't burn it, but it will melt it. It has a melting point or a boiling point, I should say melting point, not boiling, but it has a melting point that starts at 5,500 degrees this next step. And this is 10 times stronger than those. And this would be like, well, it's just lunatic strength. If you built a house out of this, man, you could hit it with a dozer. You couldn't tear this up if you tried. And it holds organic beautifully, is what I'm trying to get at. The next ones turn organic to crystalline stone. That's the difference in the chemistry. And so, like, you couldn't burn your way through granite. Well, the next ones you couldn't lance your way through either. But okay, YouTube, I thank you for your time. And like I said, this is non-toxic stuff, all what I use. And I don't believe you should be poisoned in your own house. And hemp can not only lock away, sequester carbon dioxide as it's growing and grow faster in a 20-week period than a forest of 20 acres can do in 20 years. But it can sequester the radiation from bad ground, from dirty soil, and it can sequester, it can bring up and trap the, what do you call that? The pollution from oil spills. It's quite a unique plant. And so like a border wall, back to that, a border wall built to that, yeah, you could sequester quite a bit. Is security real? Yeah, it is. Do I want a border wall? No, I spent my military career taking down walls. But is it real with our business plan for the global? Yeah, and we're not going to change. We're capitalist and we're greedy, and it's not going to get any better. So we might want to consider something different, but make it green and as toxic as a vitamin. And even those, the next 5, literally as strong as super strong as those are, they're still only as toxic as a vitamin supplement. That's the whole thing about this. There's nothing toxic here. And people that dog Portland, okay, yes, they do put in it's like a bentonite. It's an ite. It's a clay, but it's a triite, and it has to be heated, and that it gets its bad name because they're not only heating the volcanic material, they're heating the lime, and they're heating this clay to make it super dry to make the mix. Could you do that with lime in your own bentonite? Yes, you can. You don't have to have it like that. And that's basically what this is. And it's just as strong as, quite a bit stronger, actually. In acrylic monomers that can grow roots into organics that allow the minerals to actually bind. That's the next step up. And then you progress on. These are PLA type adhesives and stuff like that, waterproof below the waterline. Well, I thank you for your time. Hempcrete. It's the bast, the fiber of that industrial hemp plant, and the woody shiv. And this one is it was hardwood. Basically, it's the strength of a hickory, a hardwood hickory, and the weight of maybe I'm going to say a bass or a balsa wood. Some pieces that I've worked with here I've been making to show it off. This was actually a show it off, but it failed. Still lifted a ton truck. It's in one of the videos, and that's hollow. I can show it later. I'll pick them up and move them around. This is a box beam. It was considered, like this I-beam, and that's 3/32 by 2-inch web. Incredibly strong. I mean, I didn't push it to the point of failure. It's a polyester resin that I used. I would trust a PLA, an outdoor adhesive, far better than anything adhesive-wise for using with the hemp, composite-wise. Shiv, the bast, a hydrated lime is fine. Portland is good. The only thing is with Portland is you're going to have clink. It's the clay. It's the secret of Portland. I didn't give nothing away. I think they have that in the encyclopedia somewhere. But let's get off that. Yeah, is this is the damage from the torch. Somewhere I thought I had it. I don't got the torch in view, but this is a pock mark from the torch. Basically, it was about an hour burn that did that, and then I roughed it up. When I cut it in half, the saw was like beating it, and that's what did most of the damage here. And I gouged it with a screwdriver and all. And the same thing goes for this. There's a big gouge mark right here. As I sunk this down, it was surprising that this fiber, it doesn't take on water. And I submerged it for, 24, 48 hours. I don't remember. It's in the video too. And with a ceiling tile. So look for that one. And then I gouged it to see if it had water in it, and it didn't. And so I cut it in half, and that's why there's 2 lopped up pieces. It's actually insulation about the weight of blue board. Incredible strength. In one of the videos, it's like holding up this way, the weakest way it could be made. Now that it's cut in half, you can see it's made. It was holding this way at like 180 pounds. Had it been together and turned, on edge, it would have been actually incredibly strong. Everything, it always fails at the point of its adhesive. Keep that in mind when you're working with this fiber. The adhesive is its weakest link. Like a polyester adhesive, if you strike it hard, it'll shatter the adhesive.
Doesn't mean the fiber breaks, but it's going to make a weak spot is what I'm trying to get at if you hit it hard. A PLA, you can hit this as hard as you wish. Watch another video. I'm hitting this thing like a monkey, dude. Now I'm swinging a hatchet. I don't know if I can, yeah. This hatchet, but it had a yellow handle back then. It happens out here. But, stuff breaks. But I'm swinging this thing like a monkey boy, and it's not even deflecting the tube. It is bending the 3/4 inch OSB cover, the bore. I was beating on it about right here. And the only thing that stopped me from beating it worse is the cup. My camera was taped to the cup, and it was walking the cup off. And that's my puppies out there, if you heard them barking, and they probably found the other glove, and they're happy. And because I lost it doing the last video. And what else can I tell you about that? Oh, this is strictly bast fiber. And to give you an example, that's 3/32. So if you would make this like 3/8, 1,000 pounds in any given point would be no problem for it. In this way, yeah, there is no, you can't measure its strength this way. And all that is just biaxial. It's a weave and then put together and pressed. If you want to play with this idea, I would strongly suggest, again, an outdoor PLA versus the polyester, only for striking. If you want to like shoot nails through it or something like that. Something slow like a screw, be fine. This, have a ballistics test. This was purposely made hollow because what I was wanting to do is show off its castability. And I really wish I could. This is where I couldn't see it outside at all. But now you can see it's like completely failed. It's not compacted, it's loose. There's a hole in here. Actually, I looked around. On the inside, you can see 2 or 3 daylight through them. There's one where you can see daylight through it right there. But the camera doesn't do it justice, is what I'm saying. It's a complete casting failure. Yet it still picked up my ton truck. The only thing, my crippled butt, I tried to race up and get the camera to get captured on video because I thought it was going to break. I don't think you could actually hurt this thing. Now that it's down and I looked at it, because it didn't give up nothing. I'm going to take it back out and try to lift up the front of the truck now, just to brag, because before I didn't even want it on video. You don't want to brag about your failure. Not too much, I'm a good hillbilly guy. And, but, it's just down to earth. I'm being honest. And, but now I can actually brag about that, dude. I might even cut the top off level to make it fair for the thing. It was lifting it up just fine, even as crooked as that is. And held it while the truck rolled. It had slack in the transfer chain. So, that's saying that I'm happy with that one. To clarify some stuff, this is organic I-beam. It's bass fiber, the stringy part of the hemp. It's used. This is with epoxy, so I've not beat on it or nothing. And it was a really cheap epoxy too. You can get epoxy that can be struck, and this one just can't. Any kind of real blow, the epoxy will shatter is what happens. So I've not really tested this one. It can support, a few hundred pounds, and it's 3/32 of an inch, the web, and it's only 2 inches tall. So, comparatively, if that would have been, say, 3/8 or ½ inch thick, with just, maybe a 12-inch web, something real, it would be, it's more than structural, is what I'm trying to get at. And just change the epoxy so it can be struck later. That was just one thing I found out, the weakness on this epoxy that I bought. And I ain't going to badmouth nobody there. That was my fault. This one is what I was trying for here. And this is what the whole video is kind of about. This was handmade, and so I was looking for a way to machine it, to make it, manufacture it. And so I was coming up with a column, and one thing you want to do, the PVC works extremely well to mold it, and you can even heat the ends of the PVC, shape the PVC into the shape that you want it to extrude, just like you would extrude aluminum, and just make a pass-through system. And I ain't, telling anybody no great big things there, but can it be done? Oh yeah, I have no problem. But the one thing I was wanting to say is I used to use 6-inch ingot molds, and I was thinking, man, this is coming out really good, and so let's step it up and make it bigger and taller so we can extrude something and step it up to the next notch. I forgot to wax and carob them. I'm a redneck hillbilly, so say that right when I say it wrong. But get this kind of wax, not so much the name brand, but it is a good wax. I mean, these guys did a great product. But if you wax the inside of your PVC, it'll never do this. And this is a PLA adhesive, so it will stick to almost anything, but not that. But what I'm going to do is chisel some of that out, and I'm going to repair the worst of this column. I think that's yin, that's worst. And then I'm going to wrap it with a girdling of bass fiber. And it's kind of cheating. I know I probably won't test it, or I will outside the realm, because the girdling, you'd think, well, that's just silly cloth, but it's bass fiber, so it's no longer silly cloth. Everything about this stuff, you got to remember what it was made from: hemp, which is stronger than steel. The bast is. It's stronger than concrete. It's lighter than concrete. So many properties, it's crazy. But to get back to this, I'm going to cut this in half, use the bottom half for testing, fix the top half, and then wrap it with a girdling, and probably test it for strength. But it'll kind of be cheating because the girdling makes it too strong. And but here we have one that's in Portland. This is everything's the same thing, the same generalized mix. Now, one thing I do is check out another video down there somewhere. Is this stuff is purposely not ground, that's a bad term, crushed. It's crushed and kneaded, and that's what makes it this crazy level of strong. It's strong enough just the way it is. I mean, this would be almost like anybody would build a house, except it's been purposely crushed to make this. And this is still fresh, but it has a distinct ring to it. And in reality, I would have put about 1/3 more lime into this, but what I deliberately shorted it is I wanted to show people the structure. People don't realize when it calcifies, it's basically turning it to bone. Now you can change the composition and do magnesium oxide and chloride, and both magnesium chloride flake, and change this to stone instead of bone. You change the hemp lime to a stone deal, and this was with the epoxy, and this is a pretty unique one. The most dense I've gotten it, and basically it's just the addition of bentonite. I cheated it with this. This is a thin set material that just has bentonite in it, and but definitely I can't make them ring with one hand. But it has a ring like stone. I mean, it's. And no, my casting is not perfect, and I have no pressure to extrude, and that's why a lot of my stuff is not perfect. And so when I test it, know that it's imperfect, and when it still can do insanely strong stuff, if it was made correctly, then it would be insane. The properties of what I'm trying to get at. Now, this is a front end, and I was so vindicated today when I set this all up. I don't know if the video is going to pick it up, but see the discoloration in the adhesive? It froze. So this was just put out before its time. It was literally lifting a 5,500-pound front end when it gave out on the third lift. It was still holding up the truck, but it gave out. I didn't, at the time, it was covered in frost, but it was -7 that morning, and it had snowed that night. Southern Colorado snows vertical here. It can come in, horizontal is what I'm trying to get at. And so I didn't think nothing of it until I brought it up and I looked at it again. I made it into a planter. And so there's no toxicity to any of the stuff that I'm using. Even Portland, before people berate Portland for what it is, the difference between Portland and lime, which is hydrated lime, is which I used here, is only a few hundred degrees. They produce just as much carbon dioxide into the atmosphere. This goes through another process which adds more. Give them that. You change that to magnesium, which is basically like a health food product, and you won't have that. But for certain properties, as I was going for fire resistance on this one, down there's another video, and what this went through was just wrong, but it did degrade a little bit. It degraded with about 1.5 inches where it dug out, and that's what got the hole for the planters, where I had a torch like zeroed in on that spot. And when I did all this, the thermal damage got to about here, which this is maybe 5 inches, so maybe 1.5 inches of it, and but the rest of it's pretty solid. But it look at the other videos. I don't want to say something and then say something wrong, but for the damage and the length of time, it was like over 600 degrees for like 9 hours. It was a ridiculous test. In reality, you could have dumped gasoline or diesel fuel on the home, lit it on fire, the gas would have burned out well before this test would have ever run its course. And it was a 3-term test. So that's what this thing lasted through was crazy. I have made it, like I keep going back to the magnesium, and you can make it 100% fireproof, where you couldn't do this damage even if you tried. It's just not possible to damage it anymore. And it petrifies it to stone. But what happens is, like this, I was deliberately trying to make it dense because I want to make an outer column wrap. It's strong enough to support quite a bit of weight. But what I'm looking for is to thermally hold energy, to wrap it in PEX tubing, 18 inches around. Wrap it in PEX tubing and then finish it off so the columns in the house are actually a source of heat for the home. And another thing I got to say about, and no matter whether it's lime, like this where it has bentonite in it, a thin set, it's called stabilized is all it is. It's stabilized Portland, or stabilized lime. Either way, thin set is just stabilized. It has something in it, whether it's acrylic or latex or bentonite, to make it sticky is what it comes down to. And pliable so it can be struck. This can be struck where this can't. This regular Portland is on a 3x6 ingot like this, can only lift up 2,000 pounds. That's it. It'll shatter before 2,000 pounds. Now this has the hemp in it. It's considerably stronger. Wrapped with a girdle, it's exponentially even stronger yet. But can it crack and all that? Yeah, it can. One of the biggest tests that I want to do is I want to take the girdling and this is extremely light by comparison to the rest of these, is I want to take the girdling in this and then mix it with magnesium and turn it to stone and see what kind of properties that has. And especially for the thermal mass, that's another thing. And but this was an extruded project, like I said. Do as I say, don't do as I did, because you will really hate yourself. Wax the mold. It comes out really nice. Use a good wax. This Carabum, whoever the manufacturer is, that's probably irrelevant. But these guys, McGuire, I'll name them off. They did a great job. I've used it for for all kinds of molding. It will release everything from everything if you remember to use it. That's the one big key. And what else to say? That's about it on this video, I think. I think I've covered every question, especially this one. I got to redo this one. This is hollow too. This has less material than a 3-inch ignet, and it's 5 inches diameter, but less than 1 inch in band. So it's basically like a piece of OSB. And like I challenged anybody, you try to pick up a 5,000-pound front end of a truck with a piece of OSB, Jethro, it ain't going to work. That strength, that's unreal. But it was the adhesive. It just, again, and I judged it prematurely when I said it, but I wasn't wrong. The adhesive failed. It froze, and it even discolored quite a bit. So, but what else? That's it, folks. I thank you for your time, and this is all hemp, and it can do way, way more than this. This is the plant that needs to be on planet Mars. Not only to breathe its atmosphere, but to give us back oxygen, to provide any form of building material. The seed can provide the oil to make an eco resin way stronger than any of this. And the plant itself can make itself fairly strong. You can pulp this down, the same material right here, pulp it, put the magnesium to it, and literally turn it to stone in any thickness. The thickness of, like this. I mean, what would you do with a stone I-beam? I'm not real sure. But like to do the girdling, or, the fabric, the bast fiber, you could drape that. The bast is not going to go anywhere. It's good for about 70 years. I mean, it's not going to rot. It's not going to do any of those things, just unaffected. Bury it in magnesium and a magnesium cement. Bury it in regular concrete. It's fine. It's super strong. Bury it in a thin set kind of material like that, a stabilized Portland lime. The product didn't tell me if it was Portland or lime, so I can't tell you one way or the other. I'm going to say it was more than like lime than Portland, because people normally brag about Portland. And here was another one too. I forgot all about this one. This is just orientated. The strength on this one, check out the video. It's holding up like 300 pounds in its just fiber. That's it. Nothing like a ceiling tile. I mean, literally, nothing more. And everything here is extremely light. The material is light as balsa. So, but the strength is not there. Check out some of the other videos, like I said. And if you like them, hey, do that like and subscribe thing, wherever them buttons are, And I appreciate for your time just watching these videos. And I know they're abstract and they're quirky and all that kind of stuff. And I do appreciate your comments, and I enjoyed answering them. And if I can show you a better way to do this and make it stronger, I'm all about that. If you want to do the Puritan limestone, hey, I'm not knocking this stuff. Listen, that's petrified, and that's less material than I would normally use. So it would be better than this, is what I'm trying to get at. This is just to show people what it looks like on the inside. You can't show somebody this and say, oh, it looks like that. People don't have an imagination. I mean, they just see that, and that's as far as they go. That's why some of these are cut apart. On the outside, it looks like how it was cast. On the inside, quite different. Let's see that. If you can see it. There we go. See, on the inside, quite different than the way it was cast. So that's why I do what I do, and that's why this one was done like it is, but it needs more to make it like you would make a house. This is less. This is way overkill. This was for thermal mass, and it is the definite winner. Bentonite. Add bentonite if you want thermal mass in your stuff. And powdered sand. Get the sand as powdered as you humanly can, or use limestone. Same thing. And limestone, I'm thinking, is going to be the wonder for the magnesium also, for thermal mass. Because magnesium has one property: it cannot transmit thermal heat. And this cannot transmit thermal heat. Check out the video. 600 degrees for 9 hours on one side. The top of the tile was less than 5 degrees. Never got more than 5 degrees of ambient air. And that's over the top of a wood stove that was raging, that I had to keep open and fed to get it to those temperatures. And so the material can handle way, way more than its binder. And that's what we're working on now, is a magnesium binder, a stabilized magnesium binder. And the stabilization would be for thermal mass or for, heat disposition. It can do that all by itself. The heat disposition, I can't say that word. Okay. Think redneck hillbilly. I'm sorry. Dispensation. Yeah, dispensation of it all. And again, when you're doing your testing, remember the bass fiber, it changes everything, the girdling. And if it's put on like this, there you go. It has to be, boy, I have an ex-wife and she would know what that's called. Bias, on the bias. She was like the wizard of sewing. But I think that's the name of it. But if you put the girdling on that, the bias, the cross of the thing, just exponentially stronger again. And any of these could be extruded through the, being made with a machine. The girdling could be added afterwards, after the extrusion, before it's cured. The girdling can be added straight into it. The girdling actually even holds like a texture. I've used it here on the counter. I played with it. You can do anything with it, is what I'm trying to get at. There's not much you can't do with that material. And it's hard. It's extremely hard. Okay, that's as far as I can go on this. And way, way long and windy, and if you made it to the end of this, may you be blessed. I thank y'all. And again, thank you for your time and support and all that happy stuff. Not like anybody gives me nothing. But if you do, adhesive would be good. Material would be great. I got some contact for that. Other than that, I don't know. I need a few test projects. You want to build hemp? Let's go.